You and I have talked about the three pillars of Atlas. Okay, so we've talked about your cable, our promise. We've talked about the performance levels, our upgrade, our aspire, and our high-end ranges. But I would say probably the most fundamental one, which has been something that's happened since day one, is the 5 essential elements of Atlas. And it's a real founding principle of what we do here, isn't it? Can you talk us through these elements, please?
Yeah, hopefully. So our philosophy is that cable design, it's an engineering material science, and it's a process. Right? And what I mean by that is that we believe that all cable type, their performance can be characterized in 5 essential elements. And that is to do with the conductor quality, the dielectric efficiency, the plug quality, the screening efficiency, and the manufacturing process.
Great.
So whether you're talking about, for us, whether we decide to design a power cable, a streaming cable, an analog cable, a headphone cable, or any other type of cable, we start with these 5 elements. And because we've got these 5 essential elements, when we do the basic rough design and we choose the conductor, or we choose it, we effectively, we know at that point roughly where the performance is going to come out. Okay. Obviously, when you get to the final product, you might, things surprise you, good and bad, and then you have to assess it. But basically, the design philosophy of Atlas is based on these 5 things. Okay. And so it's a recipe and it's a methodology we choose. So give an example on the conductor, because we use primarily 2 types of, likely 3 types of material, conductor material at Atlas. We use high quality oxygen-free copper, OFC copper, and the majority of people use that. Our preferred material, however, is a material called OCC copper, is Ono continuous cast copper. And it used to be a patented process. It was designed by Professor Ono from the Chiba Institute in Japan. And he developed this process, which was, they call it long crystal or long grain copper. And it's the process by which you extrude the copper, but under very controlled temperature, oxygen-free environment. And by doing that, you can pull a piece of copper so that it has a very long internal crystal boundary, right? Because we believe it's at the crystal boundaries where you get the impurities lie, and it's the summation of all these impurities that's where you lose information. So OCC copper and our Racimi product at the very high end of our business, we use an OCC solid silver, are fundamentally part of our choices when it comes to conductor material. Okay. When we move on to the second choice, which has been down the essential elements, part 2, dielectric. Dielectric is I think one of the most important and undervalued areas and understood areas in cable design.
So it's maybe not something that everyone's aware of in terms of how what is a dielectric to begin with, So
because people look at it simply as insulation, and that is fundamentally a lot of cases what it's there. It's to insulate one conductor from another. However, it's got in the audio world, it's got a far more sophisticated application. Okay. And that is that every material, the ideal dielectric is a vacuum. It's if you put an impulse down a conductor in a vacuum, it goes nigh at the speed of light. If you then let air round about that, so you've taken it from space and you've brought it back down to earth and you have air in it, and you put the same impulse down that conductor, it goes slightly slower, 99.9999, and that's related to air as I've got a dielectric constant. If you then just decided that you were going to make a cable one day and you decided that you would just cover it with PVC, which is the most prevalent insulator in the market, you might find that you lose, 50% of the speed, right, now, of that impulse. So the impulse that used to go down at 99.99% speed of light is now going down at 50%. And that is because that the interaction, the surface where the conductor and the dielectric meet is a place where you get an interaction electrically, and that's where you get slows the signal down. The speed there doesn't mean in the traditional speed velocity. It relates to bandwidth, and bandwidth is information. The wider the bandwidth of a cable, the more information that cable is capable of transmitting.
Okay.
And in bandwidth in an audiophile sense is better sound quality, more dynamics, more detail, more realistic. I mean, we call it more accurate, more natural, more open.
Yeah.
So you can engineer performance of fundamental cable over two areas, the conductor and the dielectric. Now, you could theoretically get to that point, and that point is, you think, I've done it. And then you decide to make a product, and a product requires taking a cable and then putting a plug on it. And that's where a lot of people throw away the performance. So at Atlas, and it wasn't conscious, it's a kind of unconscious decision 25 years ago when we chose our preferred materials, OCC. We realised very soon, very early on, that the material, while it was good, had a negative, and that was it didn't like called post-processing.
Right.
And that meant it didn't like the application of high temperature dielectric or indeed soldering after it was produced.
So you're almost reintroducing some of the impurities that were negated with the process of OCC in the first place.
So you've spent your money on purer materials, and then you go to manufacture it, and then you kind of corrupt it. So we had to then go and say, well, how do we overcome that? Because we're engineers, how do you overcome that problem? And so cold welding or crimping was a solution. That solution led us then to think, well, we can't use standard parts and plugs, so we had to design our own plugs. And because we designed our own plugs, then we could cold weld it. Great. One of the positives from that was that because we made our own plugs and because we could cold weld them, we are now in charge of the material and the plug. So if we match the material and the plug, the pins and the plug to the material and the conductor, and if it match the dielectric and the plug to the conductor, then you suddenly get, again, this area where you're losing less and less information, and your fidelity is increasing. So that is part 3. So conductor, dielectric, plug quality.
Okay.
All matter, all contribute to adding fidelity. And as we've touched on earlier, more and more, then you need to look at screening as one of these. We've got a pillar, but it's one of the 5 essential elements. We have to look at every product we make: headphone cable, power cable, streaming cable, USB cable, analog interconnect, a different tactic for the screening, because every one of them needs to be screened, but in the context of the application. Of course, what's pulling all that together is over the 25 years, because it's our 25th anniversary this year, is that the manufacturing process. So when you go to a factory, all our cables, nearly without fail, are handcrafted. They're individually crimped, signals and returns, and that crimping, because we've had to develop our own tooling, has given us one other major advantage, we believe, over our competition. And there's many good brands out there and good competitors, is that if the both of us went out to the factory and we both obtained some components, and we made a cable to the same specification, to the same recipe, and we come in and listened to it in the demo room. I'm absolutely certain they'd be different, because we would solder the connections completely different.
Yeah.
We'd apply heat at different times, we'd apply different materials, different amount of materials, and that in itself would be a problem for us. So one of the advantages we've got in our manufacturing process, because everything is controlled with controlled tooling, is it doesn't matter who makes our product, they're identical. You know, if we made a speaker cable, took some speaker cable and took some crimp plugs and taken it into the other side of the world and made a speaker cable, it would be identical to the one that was made in our factory today.
Yeah.
And I think that's another important thing for customers, is that once they've heard a demo in a demo room, they want to ensure that they're going to get that performance in their home. And with Atlas, we can guarantee that, because we know that everyone is being produced identical.
Yeah. So we have a very consistent process throughout.
Absolutely.
Fantastic.